Hi everyone, my name is Dr. Luke Wentlent. I'm a principal R&D engineer at Plug Power, where I work in the Chief Technology Office. My role there is to look at research and development, new technologies, and new rules and regulations that are being put in place around green hydrogen. Today I'm going to be talking to you a little bit about some rules and regulations that have been proposed regarding the production tax credit in the recent Inflation Reduction Act. A little bit about my background. I studied physics and mechanical engineering and did my Ph.D. in materials science and engineering. Since then, I've worked in academia, in various NGOs, in the semiconductor and electronics world. I've worked with utilities regarding large-scale renewable development, and finally in the hydrogen industry itself. So, in the Inflation Reduction Act, there were a number of different provisions that were put out to help accelerate our fight against climate change. Things like accelerating renewable development, clean buildings, clean manufacturing, and chiefly among them, accelerating the green hydrogen economy. That piece is called 45V. Really what that is a production tax credit that's intended to provide an incentive for the cleaner the hydrogen you can produce. So for example, if I can produce hydrogen with associated emissions of 0.45 kilograms of CO2 per kilogram of hydrogen, I get the full tax credit of $3 for that kilogram. The more emissions, the dirtier the associated process with the hydrogen, then the smaller the tax credit. Now, in the legislation, Congress, the only rules and regulations they put in place around that were that the emissions needs to be calculated using something called the GREET model. That's an emissions calculator developed by Argonne National Labs. And really what that is it's simply a calculator that allows you to plug in, where you're getting your power from, your system performance metrics and efficiencies and so on, and it will calculate for you what your emissions should be. That said, there's been a lot of debate recently over whether there should be additional rules and regulations and requirements that are put in place in order to receive the production tax credit. Now, just to be clear, all of these different concepts that have been proposed, they're not things that are in the law, they're not things that have been discussed by members of Congress, they're not things that were considered and then thrown out when the legislation was being written. These are purely concepts that are coming from outside entities, third parties. So there's several different thoughts that are out there. Probably the leading one among them is a concept called the 3 pillars, which was initially premised by and proposed by the Princeton Zero-E lab. And in that, they really said that there should be 3 additional regulations put in place. The first is additionality. The second is an hourly time matching. And the third is a deliverability or geographic regionality type requirement. There's a lot to get into. I'm going to be talking today specifically about the additionality component. There'll be other discussions later about the other 2 pieces. So the 3 pillars rationale for additionality. Why do they premise this? How do they come to it? What they're saying is that if you build a hydrogen production site, a large utility scale installation, you're going to require a large amount of power. And even if you go in contract with a renewable developer, you're going to need to bring that power to your site. You're going to be putting a load on the grid. And so even with your green electrons, the load on the grid has been increased, and the utility will then need to increase power on the grid, the power available, to compensate. And what they're trying to do is link those emissions from the grid increasing their capabilities, their production, to the hydrogen production itself. They're saying so that in order to mitigate that, you need to be able to bring a renewable project online that is expressly for the intent of that is only there because of your hydrogen production project. That's the definition of additionality. It's something that wouldn't have been there otherwise if not for your hydrogen project. That takes into a lot of assumptions, a lot of kind of oversimplifications, which we're going to talk through. But that's fundamentally the premise behind where the additionality argument is coming from. So some of those counterpoints and areas we think that the analysis might have been improved. And I want to preface this by saying everyone involved in this, I don't think anyone has malicious or ill will, that they're trying to twist the things. We all agree, I think anyone involved in this debate, that hydrogen plays a critical role in decarbonizing a range of industries, particularly hard to abate ones, and that it's a critical piece of our fight, our combat against climate change. And like I said, I don't think anyone's kind of maliciously trying to mitigate that or to restrict that, but we got to understand that if you want to really make change, we need to look at the full system, and we can't predicate it upon some of these, overly simplistic analyses and things like that. So some of the counterpoints, and we'll talk through these in a little more detail in the next couple slides, but just to summarize, additionality wouldn't really seem to dramatically change the existing power system's emissions. And that's been shown by a couple different studies, including the Princeton paper that published this work, them as well as some utilities that have modeled these scenarios that have been proposed. And what you see is that, it doesn't really move the needle too much on system-wide emissions when you look at the grid as a whole. The hydrogen production is just not going to be big enough to impact something as large as the grid in that scale, right? In addition, some of the modeling shows that it looks like the IRA has enough incentives built into it to promote renewable development to more than compensate for any increased demand from hydrogen. Modeling by utilities has also shown that the things that are really going to move system emissions are EPA regulations around coal and gas plants, whether it's cleaning them up or retiring assets, as well as all these incentives that are bringing more renewables online. And kind of to that point, the three pillars didn't really consider the broader intent, the broader strategy that the administration and the federal government's really been trying to put into play. Like I just said, there's new regulations coming online from the EPA. The CO2 intensity in our power grid has been decreasing for the past 15 years. Not as fast as we'd probably like, to be fair, but it's been decreasing because you are seeing some of these policies start to take effect. In addition, by requiring this additionality component, this requirement for hydrogen producers, you're effectively putting the burden of decarbonizing the grid upon those hydrogen producers, which is just something that's never been done before or asked of any industry, facility, sector, whatever, ever. There's been volunteer, incidents where people have, tried to put their facility on as zero emissions, and that's fine, but it's never been mandated like it would be here. And we'll talk through some of the challenges with that. Finally, this kind of one-to-one mandatory matching concept would be enormously complex to realize. In an ideal world, it's a good idea. In 20 years, when everything's figured out, it's not something that it's something to be considered, but it is far, far, far too complex to be something that can be implemented and integrated in the timing that we need and the complexity of the systems that we have to effectively combat climate change. And we'll talk through that as well. There's a couple layers to this additionality piece, and the first is that if you apply this kind of simplistic additionality scenario, you're going to drive hydrogen production to regions where it's cheapest to comply. I mean, you don't need an MBA, that's business 101, right? You're going to go to where you can comply the cheapest. So you're going to preferentially be forcing hydrogen production to certain areas of the country, and you're not going to see it in other areas, even if those other regions had very low emissions rates in their grids, because they're fairly clean grids, or they had large amounts of curtailed power. Additionality does not allow you to use curtailed power for your hydrogen production. If you look at the consequential emissions, which is the actual grid emissions that we care about, for a number of regions in the United States, it doesn't change with or without these three pillars. And that's what's being shown is the PTC as written, and then with these three pillars, included in the model, and they're circled in the black circles. And the emissions doesn't change. What that implies is that if I still manage to bring on a large amount of hydrogen and increase the load on the grid, the data would indicate that you had enough incentives to build enough renewables out to compensate for it. So you're not going to really see a big increase in grid emissions, right? And that's an important piece I think we need to take away is that, Congress doesn't always get everything right, but they seem to have thought this one through because they've already effectively included enough incentives to drive, more than enough to compensate for this hydrogen economy. And it was kind of smart of them because rather than link these two together, which is what the three pillars would do, it would link the renewables and the hydrogen production together. That just creates such a burden and such a high barrier from an economic and a project and a development perspective to actually realize. By separating them, you're kind of just allowing the market to drive what's the best, most cost-effective solution out there, what's the fastest solution out there, right? And that's really an important piece to keep in mind for all of this is speed, right? We're trying to combat climate change here. We don't have the luxury of 10, 20, 30 years to play games and work out different ideas. So in addition, there's some other limitations of additionality. And one would be that it's hard to define. We already kind of alluded to this, but the very definition of additionality means that it is something that was not there unless your project was put in place. So the burden of proving that is going to be very high, because with all of these incentives out there right now to just develop renewables in general, how are you going to be able to sit there and say that developer, we only had that solar plant or solar site built because of my facility? You could easily say they built it because there's significant incentives. So proving that additionality is from a definition, from a law perspective, would be very hard to do. And that was something that the Kyoto Protocol experienced. The Kyoto Protocol is an international program trying to drive, carbon offsets in a variety of different industries. And one of the biggest challenges that they had was not being able for projects to meet the definition of additionality. They just couldn't understand it. Could they definitively say it was additional or not? In addition, the premise of the three pillars assumes that both current and future carbon policies are completely ineffective. They're looking at a static point in time. They are not considering how things are going to evolve as you move forward. And good or bad, things are going to evolve. We know that. There's no way they're staying the same, right? And if you look at some of the data like this chart, the emissions in the US grid has been going down over the past 15 years while generations remain the same. And that's for three reasons. You've had assets retiring, fossil plants retiring. You've had existing fossil plants getting cleaned up. And you've had more renewables getting developed and put onto the grid. So that trend's going to continue, especially with all of these incentives out there. And the Princeton researchers even state as much, that regulating system emissions would be far, far more effective by doing it at a cap and trade type program, a system level program, rather than targeting hydrogen specifically. In addition, this kind of gets to the next point, is that there are significant regulations around power plants from emissions from coal and gas plants, right? And those are set by the EPA. There's a new draft of regulations that was just released this year, and that'll be finalized sometime in the next year or two. And I'm showing a chart on the upper right from some results from Constellation, where they modeled how these new regulations, as well as the additionality, would impact emission reductions and the actual emission quantities. So the 111B and 111D refer to EPA regulations, proposed EPA regulations for coal and gas plants. And what you're seeing is that with or without additionality, the additionality piece really only moves the needle maybe 1 or 2 percentage points. And this just gets at the kind of the bigger picture here, is that you can burden the hydrogen economy. You can hammer it with some really stringent regulations and restrictions. But all you're going to do is hold that back. And ultimately, you're not really going to affect the ultimate system that much. It's kind of in the noise. In addition, this one-to-one matching, as I said, is something that's never been seen before. It's a threshold that no industry's ever had. Not battery electric vehicles. It'd be akin to requiring you going and buying a battery electric vehicle to also be required to put in some solar or wind, because your battery electric vehicle is going to put a load on the grid, right? Now, there's an argument that, well, those are immediately beneficial because they're reducing emissions. So is hydrogen. If I go use it in some application, I'm reducing emissions there as well, right? The intent of the PTC was not to overly regulate hydrogen. It was to incentivize the production of it, right? So while well-meaning, the three pillars are really kind of, in direct conflict with the original intent of the production tax credit. And that's why those concepts were never included in any of the language or ever discussed or ever, put forth, right? It's because they were trying to drive and accelerate growth, not severely restrict it and put it into a tight box, right? Which is really what the three pillars would ultimately do. And just to make the point again about the regulations around the grid emissions, there's been major regulations that have been put over the last 50 years around this, and they're just going to continue to accelerate. And again, that is something, if you really want to model a scenario, that needs to be included in the model, because that's a significant first-order impact that you can't overlook. Kind of to my point then about hydrogen can make an impact right now. A lot of the proponents of the three pillars like to say, well, like I said, battery electric vehicles are directly reducing emissions that would have otherwise come from an engine. Sure, totally agree, right? But I do the same thing with hydrogen. I can go put it into shipping or steel or into a bus, or I could blend it right into a power plant if I want, right? And you're going to get some reduction in emissions. There is a gain there. It's not like I'm just building up a big tank of hydrogen and just sitting on it, right? You're actually doing something with it. And so this chart, this table by the Rocky Mountain Institute shows that for every kilogram of hydrogen you deploy in one of these 5 applications, that's the corresponding kilograms of CO2 that you'll remove. So You can't just say, well, battery electric vehicles are going to directly reduce emissions. So would hydrogen. Just depends what you do with it and what you put it in, right? And that's only going to increase as the grid gets cleaner, as more renewables come online, right? And that's what those two graphs are showing on the bottom, is that, yeah, with the grid mix right now, there would be some emissions associated if I ran my electrolyzers purely off grid power and nothing else, which isn't what people are proposing, but if they did. But even at that point, by 2030, because the grid has gotten cleaner, you're going to see a continuing reduction in those emissions and a continuing benefit from a carbon emissions standpoint. As the grid gets cleaner, the positive benefit of electrolytic hydrogen will only increase, right? And the other piece to this, so the other counterpoint that you'll sometimes get is that, well, these industries aren't ready. Steel's not ready. Ocean-going vessels aren't ready. Why do this now if they're not ready? You're effectively increasing emissions and I can't decarbonize it. And that's true. Some of these industries are 3 to 5 years away. Not all of them. We're doing this now in things like material handling and on-road mobility. But some of these big, heavy industries are still requiring some time to mature, right? But that's not, you don't wait until they're ready before you go and then you start developing your supply, your supply infrastructure. If you do that, you push everything back 10 to 15 years, right? It will take a steel plant, admittedly, at least 5 years probably to convert over to be able to, fully decarbonize with hydrogen. So you don't sit there and wait for the steel plant to come to you and say, all right, now we're ready, everyone. Now start your production projects for the hydrogen. So give me another 5 years, guys, and then I'll be able to bring you that hydrogen. It flies directly in the face of what the IRA and the production tax credit was intended to do. You need both of these things because there's such complex systems and such time-intensive systems. You can't turn one of these over in 3 months and 6 months. You need these things to come online roughly at the same time, or at least being developed concurrently, right? There's also interconnection challenges that we need to talk about. Right now, the U.S. electric grid backlog is absolutely staggering. At present, we have about 1,200 gigawatts of power installed across the U.S., any asset, fossil fuel, renewables, whatever. There's about 2,000 gigawatts that are backlogged right now in the interconnection queue. So what that is if you want to go and build a big solar farm and you want to hook it up to the grid, you have to submit some paperwork within your region and the governing authority to say what you want to do in your project and the metrics around it. And then they have to study it, sign off on it, and agree to it. And that's the interconnection process, right? Going through that approval process to be able to actually develop your project. Then you get to break ground. Right now, it's about 35 months, about 3 years just to go through that approval paperwork process to where they'll say, go ahead and get your shovels out and start digging, right? So that's just to say yes. Then you have to develop it, right? That's a 5-year project. You don't have the time to wait for some of this stuff to develop and mature. You need to be doing these things concurrently, right? The other thing to just keep in note is we talk about the grid getting cleaner. About 1,300 gigawatts that's in that interconnection back queue are renewable power. And you can see the breakdown in those figures on the right. So depending on where you are in the country, that's going to vary from how much and what type of renewables. But there's significant amounts of renewable projects coming online. It is the absolute wild west right now out there if you're trying to get into that area. The other piece, though, to keep in mind is the burden to run these through to completion is high. It's challenging because it's expensive to do this. They're understaffed, to be honest, trying to handle the volume of what they're seeing. And so you run the risk of losing projects simply because they don't have the long-term, ability to sit there and wait for something to come together over 5 years. You need to start doing this now. And if you tie, through additionality, if you tie your hydrogen production plant to a renewable site, you create a host of problems. Not only from this interconnection component, which is also going to be getting more expensive, right? Just as time goes on, the interconnection costs are rising, but from a complexity of your projects. Right now, there's a rough estimate. If you put a project into the PJM, which is kind of this mid-Atlantic Pennsylvania, region, you're not going to see power coming out until about 2030. So by requiring a production facility to be mated up to something like that, they're not going to be able to realize the production tax credit until 2030, right? Which is almost more than half of the time that this is intended to run through, first of all. So you're kind of, again, flying right in the face of what the intent of the law was written as. But also, you run the risk of not being able to actually scale up the hydrogen production until then as well, which we can't afford. Any climate scientist is going to tell you we can't afford to wait 7 or 8 years for all this to come together. But in addition, a renewable hydrogen project is going to be hundreds of millions of dollars, for a facility. A utility scale renewable project is also hundreds of millions of dollars. To manage those two in concert is going to be an incredible feat that you would need to have of micromanagement, right? To be able to get both of those projects to come online at the same time, because if they don't, you now have a stranded asset, hundreds of millions of dollars of stranded asset. And no financing institution is going to want to finance something like that with the possibility that you can't run for a couple years at a time. In addition, you have to consider the integration into the grid. You can't just simply put up, hundreds of megawatts of renewable power and load demand down wherever you want. You have to plan that out far, far, far in advance. And this is something utilities are all too aware, because it's something they're dealing with right now with all the renewables. There's siting issues, there's environmental assessments that have to be done, grid congestion, grid constraints and capabilities, right? All of this has to be taken into account when you try to put utility scale projects on the grid. And that would provide another large burden to realizing any of these, right? What I'm really just getting at is that there's enormous complications with trying to really realistically impose an additionality component, and it would set the hydrogen, production, the green hydrogen production economy back at least 5 to 10 years, if not more. Finally, thinking about it from like a facility, operations, a lot of the 3-pillar proponents have been saying, well, renewables are intermittent, so you can just turn your facility down to 50% capacity or something like that when the renewables aren't available. Okay, yeah, that's an idea. But the reality is that renewables are highly intermittent. And what I'm showing on the right is charts from New York State of the wind and solar production in January 2022. And you see where the red arrows are is regions, multiple days where you had capacity below 10% or so. When you build these utility scale facilities, you're going to have off-take agreements in place. This hydrogen's going somewhere. I'm not just going to make a ton of hydrogen and sit on it, right? So whoever you're supplying this to, they're going to need a steady supply because their operation is going to be predicated upon that. Now, if you say, well, I got to turn down 50%, I'm going to reduce my hydrogen output, that is not going to fly with them. I can't tell a steel plant, hey guys, turn everything down for a couple of days until the sun's back, and then we'll be able to get you back to full speed. That's a hard stop, right? It's just a non-starter for the way these industries operate. So the only way, if you impose the 3 pillars, the only way to compensate is I'm either going to have to massively oversize my hydrogen production facility and build large storage, and then so I can try to generate a lot more hydrogen in times of renewable availability so that I can ride it through the low times, which just doubles or triples the complexity and cost and size of your project. Or you're going to have to deploy a significant amount of batteries, which are going to need green electrons themselves to charge to ride you through. So counterpoints, just to summarize, in an ideal world, additionality makes a lot of sense, right? It's something that could, it's not a bad idea. It's just the world's not ideal. We wouldn't be in this situation if the world was ideal, right? And so we got to look at the realistic implications of putting something in place like that. It wouldn't really change the existing power system's emissions. The Princeton model showed it, Constellation showed it, other researchers have showed it. The real thing that's going to move emissions on the power system is rules and regulations around the coal and gas plants and incentivizing more renewables, but not putting an arbitrary, kind of bizarre restriction on hydrogen. You want to really decarbonize, not just pump more incentives into renewable development if you really want to go that route. And that's what the PTC did. That's why they wrote it the way they did and why they didn't include any of this language. In addition, that analysis, which says there could be all these associated emissions, is not including the point that the grid is going to be getting cleaner, that there's significant regulations and laws out there, and there will be more coming out that are going to clean up the grid. The easy example is the EPA regulations. They just released the drafts of, right? Hydrogen can make an impact right now, and it needs to be scaled so that it can make it has such potential but it will never be able to realize that potential if it doesn't start to get scaled now. Hydrogen has the ability to completely decarbonize steel, which is about 8 or 9% of the world's emissions. You have to be building green hydrogen at scale to do that because of the volumes they would require, and that's just steel. But that's a significant portion of the world's emissions alone. We're not even talking about the other industries, right? So you've got to look at that full picture and got to look at the timing it takes to get us there. So we have to jumpstart this. We have to get this ball rolling now, or we're going to miss the window. And then just finally, this one-to-one mandatory matching piece is just a bizarre, it's a requirement that's never been asked of any industry. If you want to put this into place, then any new facility coming onto the grid, whether it's energy related or not, should also have that restriction imposed. You can't pick and choose like this, because what you're doing is you're pick and choosing market winners, right? And that's not how it works in a capitalist society, right? You want the best, the best solution to win. And then, just kind of summarize, the intent of Congress wasn't to overly regulate the production. You would have written this completely different if that was the intent. If you wanted to regulate green hydrogen, there's many things they could have built into it, but they didn't, because that wasn't what they're trying to do. They recognized the need to scale hydrogen. They recognized the role that it could play in decarbonizing a whole number of different industries. And they recognized the time it's going to take to do that. And so that's why they wrote these production incentives, to kickstart that production, to kickstart this whole green hydrogen piece, because otherwise it's going to take so long that you're going to miss the window. So that's all of that on additionality. Thank you so much for the time. I really do appreciate it.